Assalamualaikum. Hi everyone. So this is another video on chapter 2 to chemistry. We are still in subtopic 2.3 Hess's law, and at the end of this lesson you should be able to illustrate the dissolution process of ionic solid, and we're going to do also some calculation regarding the dissolution process. So now let's start. Dissolution process of ionic solid. Dissolution of ionic solid is a process where an ionic solid compound dissolves in water. Okay, so what is the example of ionic solid compound? So the common example is NaCl. So our NaCl exists as solid. When we put NaCl inside water, inside a solvent, so it will dissolve and it will form its ion. So what are the ions for NaCl? It's Na plus and Cl minus. So when it dissolves in water, what happens to this ion? It will become in aqueous state. Okay, so Aq, both will become in aqueous state to show that it becomes a solution. Okay, so the process of dissolution will produce a heat change and can be shown as enthalpy of solution, or also known as enthalpy of dissolution. It's the same thing, and this is the symbol for delta H solution. Okay, why do we use the word dissolution here? Okay, the word dissolution here to shows that this ionic solid compound will break, and it will break to its respective ions. So Na plus and Cl minus. Okay, other example, for example, if I give you MgCl2. So when MgCl2 solid undergo dissolution process, it will break to its respective ions. So we will get Mg2 plus and Cl minus. And if it's dissolved in water, so the state for the ion will be Mg2 plus aqueous and Cl minus aqueous. So just now I mentioned about delta H solution, and we already discussed about delta H solution before. What do I mean by that? The definition of delta H solution. So now let's take a look on the definition. So delta H solution is heat change. Okay. If you look here, it's a heat change when 1 mole of solid ionic compound, so the 1 mole part, okay, 1 mole of solid ionic compound dissolve in water to form an infinite dilute solution. Okay, so the first thing that you need to understand, when we say heat change here, it means that the heat can either be absorbed or it can be released. Okay, how do we know it is absorbed or released? When we look at the value of the delta H. So if the process absorbs heat, the dissolution process absorbs heat, our delta H will become positive. And if the dissolution process release heat, okay, our delta H will become negative. And then based on this definition, heat change when 1 mole of solid ionic compound dissolve. So our 1 mole must be on this solid ionic compound, like the equation that I wrote down just now for NaCl. So NaCl, it must be in solid state, and then when it is dissolved in water, okay, it will be its respective ion, Na plus aqueous and Cl minus aqueous. So the one that you need to make sure is 1 mole is our NaCl. Now let's talk about the stages of dissolution process. So dissolution process will come in 2 steps reaction, or 2 stages, where the first one is breaking down the crystal lattice into isolated gaseous ion, and this will involve the enthalpy of lattice. And the second step, or the second stage, hydration of the separated gaseous ion by water. Okay, this one will involve delta H hydration. So the step of the solution process, it must be and compulsory be like this. Okay, where first break down the crystal lattice. Okay, why do I emphasize this? Okay, when breaking down something, what will happen is we start with solid. Okay, solid, and ACl solid. So when we want to break the attraction between the NaCl, what will happen? It needs to absorb energy. Okay, when it absorbs energy, the delta H lattice over here, it will have a positive value. Okay, that's the first one. The second one, for the hydration of the separated gaseous ion. So, first part, the NaCl will be break down into its ion, Na plus and Cl minus. But when we talk about lattice enthalpy, lattice energy, the ions will always be in gaseous state. Okay, so that's why we have the second part, hydration of the separated gaseous ion, meaning the separated gaseous ion here, it refers to this part. Okay, so the second part, the hydration, we want to change from a gaseous state to an aqueous state. Okay, so this process, so Na plus gas plus Cl minus gas to become Na plus aqueous and Cl minus aqueous. This process will release heat. So when it's release heat, our delta H will become negative. Why does it release heat? Because when it starts to become an aqueous solution, the attraction between the ions becomes more significant. Okay, forces, intermolecular forces are starting to form. So when bond is formed, what will happen is energy will be released. So that's why the delta H will become negative. The dissolution process just now can be shown in an energy cycle diagram. So this is the energy cycle diagram for the reaction. So if you look here on the energy cycle diagram, what do we have here? The target equation up here, it must be delta H solution to show the dissolution process. So the dissolution process is from the solid to its aqueous ion. Okay, and then down here, we have first the solid dissolution, okay, to become its gaseous ions, where we have our delta H lattice, and then we have over here the delta H hydration, where the gaseous ions are hydrated. Okay, so if you look here, if we want to calculate the delta H solution of the reaction, okay, by using this energy cycle diagram, what you can see is you can try to find the arrow clockwise and anti-clockwise. So it's the same thing. Here we have the clockwise where we have delta H solution, and the anti-clockwise we have delta H lattice and delta H hydration. So before I proceed, I want to talk about delta hydration over here. So the one given to you is for the overall hydration, meaning for both Na plus and Cl minus. But some question, it might separate the value. It will give you specific delta H hydration for Na plus and delta H hydration for Cl minus. Okay, so you need to make sure that you understand when it talks about hydration Na plus, what does it mean? It means that Na plus gas to become Na plus aqueous. Okay, and then the same thing when it give you delta H lattice, the value over here positive, so it will always be from solid to its gaseous ion over here. Okay, so with that, the enthalpy solution can be expressed as delta H solution equals to delta H lattice plus delta H hydration. And please be very careful, especially for the delta H lattice over here. You need to make sure that the value of delta H lattice that you get must be positive to use for this equation. Okay, and the position of the energy cycle diagram over here, it must always be like this. Okay, because this cycle, it shows a process for dissolution of ionic solid. So it must go step by step, where first one, it must go down here to break the solid, and then it goes up here to hydrate the gaseous ions. Okay, so to get a more clear view, okay, about what I just told you, we're going to look on some example questions and how we're going to interpret all the data given. Okay, now, so let's take a look on the question. So example calculation to find delta H solution. So this is example 1. So lattice energy for potassium fluoride Kf is negative 821 kJ per mole, and its enthalpy of hydration is negative 819 kJ per mole. So calculate the enthalpy solution for potassium fluoride. So over here, you are given two information. We are given lattice energy and we are given enthalpy of hydration. So you need to find what is the enthalpy of solution for potassium fluoride. Okay, now, even though the question does not mention anything about the energy cycle diagram, as long as you get a dissolution process question, or the question asks for enthalpy of solution, what you need to do is draw the energy cycle diagram. Then you calculate the delta H solution. Okay, so let's take a look on how to solve this question. Okay, so let me highlight the information that we have just now. So given to you, lattice energy for Kf is negative 821 kJ per mole, and enthalpy of hydration is negative 819 kJ per mole. So let me write down this information for you. So delta H lattice negative delta H lattice of Kf is negative 821 kJ per mole, and we have delta H hydration for Kf as well is negative 819 kilojoule per mole. Okay, please, like I mentioned before, do not straight away do the calculation. So you need to construct your energy cycle diagram. Okay, but before that, you need to make sure that you look at this closely. Okay, as I mentioned before, to find our enthalpy of solution, the equation will always be delta H lattice plus delta H hydration. And the lattice, it must be a positive value. Okay, so why do we get a negative value over here? So actually, when we talk about lattice, when we talk about delta H lattice, we have two types of lattice. The first one is lattice formation. Okay, lattice formation, and the other one is lattice dissolution. Okay, what's the difference between these two lattice? So if formation, meaning here we have bond formation. Okay, and then for lattice dissolution, we have bond breaking. Okay, that's the difference. So please bear in mind, when we talk about bond formation will always release energy. Okay, so that's why for bond formation, the delta H lattice you will get as negative, while for bond breaking, it will always absorb energy. So when energy is absorbed, the delta H will become positive. Okay, so that's why I have the information here. Okay, negative 821 kilojoule per mole. So it's actually correspond to lattice formation. Okay, lattice formation here means K plus gas plus F minus gas to produce KF solid. So the delta H lattice over here is negative 821 kilojoule per mole. Okay, but this is not the one that we're going to use inside our enthalpy of solution. The one that we're going to use is this one. We need to break the lattice, the ionic lattice, for us to get the gaseous ion. So actually, the reverse process of this. Okay, so let me use another color over here. Let me use orange for you. Okay, so the process that we're going to use for this one is actually KF solid to become K plus gas plus F minus gas. So since it's breaking some bonds over here, it will have a positive lattice and the value is the same. Okay, it will be 821 kilojoule per mole. The only difference that it makes is just it is positive. Why? Because we need the energy to break the bond. But for this one, it releases energy for the bond to form. Okay, so please be very careful about the lattice energy. So now let's continue with the question. Okay, so I hope you understand this part. So I will leave it over here. Okay, now we want enthalpy of solution, so we will start with writing down the target equation, which is enthalpy of solution. So our solid is KF, okay, solid. So it will break into its ions. So what are the ions? So we have here K plus, and then we have F minus, and it must be in aqueous state. Okay, after that, please double check, make sure that the equation is balanced. So how are we going to balance this equation? Just balance the number of atoms. Okay, so you have 1K, 1K, 1F, 1F. This is very important. Later on example 2, I will show you why checking the number of atoms is important. Okay, now, the next step, okay, to complete our cycle, what you need to do is just under each ions over here, okay, we're going to write down the gaseous ion. So since you have K plus up here, here you have K plus, so put an arrow. Okay, the arrow should go upwards and you put here K plus gas, and then another arrow over here, F minus gas. And please make sure you need to put a plus sign over here. Okay, So the value down here will be your delta H hydration. And since it only gives us one delta H hydration information, meaning it's for both. So you put as negative 819 kilojoule, only in kilojoule. And before that, let us label this delta H solution, the one that we need to find. You need to label even though you don't have the value. Okay. So this will be the second step. The first step, this one. The second step, this one. Okay, the hydration. Next, the third step is you draw an arrow from the solid KF towards here. Okay, it must be downwards. So depends if you want to do the arrow like I do just now or if you want to do it like this. Okay, both are accepted. Okay, either one which is easier for you, and then label this as your delta H lattice. Okay, this part that you need to be very careful. So right now, my delta H lattice is from solid to gas. So if you look back over here, which value are you going to use? Negative 821 or positive 821? Okay, so the one that match this one is this one. The lattice dissolution positive 821 kilojoule per mole. So that's why you need to put over here positive 821 kilojoule. Even though the one given to you is negative. So please make sure you understand. Okay, why is it negative value? Why is it positive value? Okay, so once you have a complete energy cycle diagram, then you calculate the delta H solution. So delta H solution. Okay, so clockwise, anti-clockwise. In exam, please do not write this arrow. Okay, the clockwise and anti-clockwise. If you want to write down, use pencil and afterwards erase it back. Okay, so delta H solution is delta H lattice. Okay, delta H lattice plus delta H hydration. So put the value positive 821 plus negative 819. So you will get the answer as positive. Please put the positive sign. It's compulsory to show that it's an endothermic reaction. Okay, so the answer is positive 2 kilojoule per mole. So it must be per mole. So this is the final answer for example 1. So now let's take a look on example 2. An ionic solid magnesium chloride has the following data. So given to you, lattice of magnesium chloride, hydration of Mg2 plus and hydration of Cl minus. So if you look over here, the hydration is given separately. Okay, so the question asks, calculate the enthalpy of solution for magnesium chloride. So the question still asks for delta H solution. So let's take a look on how to solve this question. Okay. So we want to find enthalpy of solution. Okay, straight away do the our cycle. Okay, so delta H solution, so Mg Cl2 solid. Okay, so break down to its ion. So the ions are Mg2 plus aqueous plus Cl minus aqueous. So here, like I mentioned before, check the atoms, balance the number of atoms. Okay, so here I have one magnesium, and Cl, I have 2 Cl. So over here, the Cl minus, it must be 2 Cl minus. So we have a balanced equation. So label this as delta H solution. Okay, delta H solution, we don't know what's the value. Okay, now, so if you are unsure about the equation over here, what you can do is, you can write down the equation down here. Okay, but it's not necessarily for you to do that. Okay, you can straight away draw the energy cycle diagram. So the same process that I did just now, once you have the first step, once you have the enthalpy of solution equation over here, the next step is the arrow, and then you put the same ion Mg2 plus, just it is in gaseous phase. Okay, and then the other one Cl minus, so also 2Cl minus aqueous. Okay, and then here I just want to emphasize on the delta H hydration. Okay, given to you delta H hydration for Mg2 plus. So the equation here for delta H hydration, okay, it will be Mg2 plus gas to produce Mg2 plus aqueous. Okay, delta H hydration is negative 1923 kilojoule per mole. So based on the definition of hydration itself, is energy released when 1 mole of gaseous ion is completely hydrated in a solvent. Okay, why do I emphasize the definition just now? Because the 1 mole must be 1 mole of gaseous ion over here. So the value given over here is for 1 mole of magnesium 2 plus gas hydrated. Okay, same goes when you are writing down for chlorine. So for chlorine, the delta H hydration is for Cl minus gas to produce Cl minus aqueous. So the delta H hydration given, the negative 338 kilojoule per mole. Okay, so it's for, the value over here is for 1 mole of Cl minus. Okay, why do I keep emphasizing on this? So if you look over here, okay, so before I forget, let's put the plus sign there. Okay, for magnesium, 1 mole of magnesium gas to 1 mole of Mg2 plus. So this is the delta H hydration. So write down the value. So delta H hydration for Mg2 plus. Okay, you don't have to put Mg2 plus over here, just put the value. Okay, negative 1923 kilojoule. The unit only in kilojoule. Okay, then look at chloride over here. Okay, the one given negative 338 is for 1 mole of chlorine, but inside our equation over here, we have 2 moles of chlorine. So what does this mean? This means that what you need to do before writing down the delta H hydration over here, you need to times everything here by 2. Meaning, okay, I already put 2 over there. Okay, hydration is 2 negative 338. So the value of delta H hydration for MgCl2 for chlorine over here is actually negative 676 kilojoule. So this is the part that you need to be very, very, very careful, because many mistakes made by students is over here. Okay, they know the equation correctly. They know they put 2. But the mistake is they just put the value negative 338 over here. It is wrong. Why? Like I mentioned before, it's for 1 mole. Here we have 2 moles of Cl minus. Okay, so that's that. The next part, the arrow downwards. Okay, arrow downwards, MgCl2 to produce Mg2 plus and Cl minus. Okay, so the lattice energy, and it's already given to you in positive value. So you don't have any problem. To make it simple, if you get negative value over here, just change it to positive. You must change it to positive, and because our arrow compulsory to be downwards. Okay, so equals to positive 2526 kilojoule. Okay, remember again, the unit must be only in kilojoule. Okay, after you finish with the energy cycle diagram, okay, do your calculation. So write down the equation first. So delta H solution equals to delta H lattice, okay, plus delta H hydration for Mg2 plus and plus delta H hydration for Cl minus, because we separate the delta H hydrations right now. Okay, separated values is given. So delta H lattice positive 2526 plus delta H hydration of Mg2 plus negative 1923, and for delta H Cl minus, hydration of Cl minus, put this value negative 676 and calculate them all together. You will get the answer as negative 73 kilojoule per mole. Okay, the final answer must be in kilojoule per mole. Can the value be negative? Yes, it can. Why? Refer back to the definition of enthalpy of solution is heat change. It can either be absorbed or released. Okay, so that will be example 2. With the end of the example just now, we have finished our subtopic 2.3 Hess's law. So, please make sure that you attempt all the tutorials for 2.3 and try all the exercises. If you have any question at all, if you don't understand, please ask me. Okay, you can always message me or WhatsApp me. Okay, I will try my best to help you to understand. Okay, so thank you for listening till the end. Until we meet again on the next video. Thank you guys.